This is a quick outline of the fixture module, the Nucleo fixture module, which is part of the Opticam Classic CAD system. Once you've installed it, you just execute or start the application using the fixture module shortcut. Once it's loaded, you'll see a typical Windows application ribbon bar interface at the top. You'll probably find yours is set to construction initially, but this is basically the main functions of the software are all listed here: construction geometry, drawing lines, arcs, circles. Then you have drawing solid 2D entities, and then also creating 3D entities. Modifications, offsetting, shrinking, etc. Editing 3D solid data, viewing options, and information, measuring and checking and dimensioning, layers and figures, layer control, etc. Putting different components or line art data onto different layers, and transformations, copy, rotate, mirror, all the normal transformation options. And lastly, really, the fixture module is where we do our Nucleo fixture functions. And what I'll do is I'll import a solid model so we can go through that quickly. I'll go to the File menu and I say CAD Import. And I'm going to open a parasolid file. It's called box_x_t. So we have with the software default parasolid text format and 3D IGES. Other options are available. And my box is imported. On the left side here, you can see my solid geometry workspace. If I have multiple bodies, maybe some nuts and bolts, etc. with this box, you see them listed here. You'd also see assemblies in there. If you see assemblies, we need to explode those, and that's explained in the online PDF you can download from our website. But the next step really is to explain to you how the interface, the graphic viewport works. Once I'm in the center of the screen, you'll see my cursor is like a little WCS rotational type cursor. So when I drag it around, it rotates. If I move to the left a little bit, it turns into a magnification or zoom cursor. I can do the same thing, drag it around. If I go to the left, it goes to a pan, and that's repeated on the right side also. So pretty simple. At the top of the screen we have our common icons, magnification. This one here toggles between 4 views. So this is basically my 4 different views of the same component. I can then click this again, and then the prompt line comes up, and it'll say, because this is the active viewport, it's saying select the viewport. There's also down here the green command line here prompting me to do something. So I'm going to pick on that view, and now I'm back in the isometric view. You've also got options for redrawing, undo, redo, options to delete things, and also, the different viewings, shortcuts, XY plan view, isometric, etc. One thing to remember when you're in the middle of when you're using the software, you may sometimes need to manipulate the view. So for instance, if I wanted to delete this box, I could click the delete icon, and it's prompting me for the items to pick in 2 places. What I might want to do is get to a component or an entity on the back side of this box, but I can't see it right now. So the little shortcut to get around that problem is to keep the shift key down. If I keep the shift key down, my cursor changes into the current viewing function. Right now I'm in rotate, so I keep my cursor down. I can rotate my view, keep my finger on my shift key. As soon as I let my shift key back up, the command's back. I can then pick whatever I wanted to pick on the alternative side of the box. So if you need to manipulate the view, just remember to keep the shift key down in the middle of the prompt, and then you can change the viewing angle, etc. When it comes to selecting entities in the software, there's several ways to do this. If I duplicate this box for the sake of example, I'll just do a copy translate, I think. So pick this box, and I'm going to press the enter, and there are a number of copies. One, I'll just say from here to I don't know, X30. Type in X30. Okay, now I've got. If I go back to centralize my viewing, you'll see everything. This one on the left, and this one's been moved to X30. Now, when it comes to selecting things, I've got 2. You can do it several ways. When it asks me to select something, I can pick each box, and I've got two boxes. I've got 2 entities down here marked in total. I can also deselect those by right clicking and say deselect. I can then also press the D button over the top of the entity and it will deselect. But obviously the other way you can select stuff is to use a window. So if I drag a window over this, if I don't get it all in the box, it won't select it. So these two components are outside my draggable box, so it got nothing. If I get them inside, we're okay. It will get them both. If I alternatively go the opposite direction, click from the top right to the bottom left, the corners go inside out. And as long as it touches, any of those 4 lines touch the entities underneath, it will select them. So typically you might use what we call the inside out window selection method. And once you've done that, you will then end the command, press the enter key, or press this green cross. And it's deleted the items. Of course I want to use these for our demonstration, so I'll just undo that. And I'll delete just one of them. Single pick, and then green cross or the enter key. Right, to get on to the actual functionality of the Nucleo fixture module, we go straight to new fixture and we go to the Fixture Wizard. My measurement system is currently set to inch. You can change it here to metric if you so wish. Go to the Nucleo Wizard and go through this, follow basically the 18 steps of the wizard. This little question mark icon gives us some help. If there's pertinent information that you might need assistance on, what a dimension means, there's a pictorial image there that will point you towards what value means what. On this page I want to orient my part, so it's come in not the right orientation I want. I could just rotate it around the x-axis and get it to be flat like this. So put 90 in and press the green check, and it's the correct way. But if it came in at a funny angle, I'll just put it back at 45 degrees. I could get it flat. I could align it to a face and line it flat to the XY plane or parallel to the XY plane. To do that, I click the Align to Face. I will click a face, so it's prompting me to select a face. It's then saying select the bodies. Well, if I had multiple bodies, I could just window everything. I could zoom out maybe and do multiple selection with my window. Or I could just pick it. I've only got one, so I'll just pick it and I'll just end the command. And I want to date it. I want to make it XY, the XY plane, and I want to keep that face upwards. If I uncheck that, the box will go upside down. So it's just a way to so you can, when you select the face, does it stay upwards, upright or not? So now it's putting it basically X0, Y0, Z0. I want to move it up a little bit in Z, so I can just press this center button. It will put it at Z2 by default, which is our default home position, X0, Y0, Z2. On the right side here, we've got typical icons for doing, functions you might want to use over and over. And also a button here for resetting the default. So if you change anything, you can click this button and it puts back a decent set of defaults for you. Now I go to the next step. Here we determine the material we're going to use to fixture the part, so the blade material and the base plate material. You can choose from a standard set of steel gauges. I'm going to use 11 gauge. And it just fills these out for me. You can put these numbers in yourself. You should measure this material to get it quite accurate, because if you make it too tight or too wide, you'll either have a fixture that won't go together properly or will be too sloppy. So it's important to make sure that you have the correct material thickness. There's a material undersize, oversize, and what that does, where these purple and green lines intersect or they interlock, it just gives us a little bit of a clearance value. So in this case, it'll put 5 thousandths per side, so the part goes together nicely. We can also put in a material thickness of this is what the software will encounter, the thinnest piece of material it might have to scan or look at. So if you had an upside down U section, if you can imagine, it would be the U, the bottom of the U shape would be the thinnest material. So maybe if it was 11 gauge, it would be 11 gauge thickness. You don't have to put an option of a value in here, but it just helps with the speed of the algorithm. But you can leave it 0 if you so wish. But it's the next step. Again, now we start to see some pictures here with some A, B, C, Ds, etc. This is just asking me how much I want to encapsulate the part, how much bigger I want the part to be, the fixture to be than the part. So I want it to go 2 inches outside the box in X and Y. I want it to go up the sides by 1 inch. And Typically you put in your favourite numbers and leave them, and it will remember them next time. For the other options, we don't really need to change those, and actually I will show you a way where in essence these two z heights up the side, the C and D parameter, are overwritten by boundaries. Boundaries give us a lot more flexibility over the basic way of doing it if you don't use boundaries, which I'll explain in a moment. On this page we do the base plate, how much bigger the base plate needs to be. We were saying 4 inches bigger, so it's bigger than 4 inches in the extent of the part. We put some radiuses on the corner. On the bottom left we put a chamfer of the same value, so you know where the bottom left is. And then in this field here, if you have a rotary axis, your head and tail stock arrangement, you can put in the dimensions of your head and tail stock, so the base plate fits the limitations of that rotary axis. These are the boundaries I talked about. These are very useful for controlling the height of a fixture, filling over holes. You can also fill holes in a preparatory sense. On this modify 3D menu, you can fill holes and gaps. But this is another way of doing it inside the wizard. I'm going to draw an envelope boundary. There's several different types. There's envelope, offset, line arc, rectangular. You can draw your own shape basically with line arc. But envelopes are most used. And I make an envelope that's 2.5 inches bigger than my selected solid bodies. So I'll click the create bounding limit option, and I'll pick my solid. It could be solids, but I've only got one. Press the enter key, and it's drawn me it's kind of transparent boundary. I'll move it down in the z-axis a little bit, just for the sake of example. You can tilt these, scale them, mirror them, do whatever you need to do. You can have different shapes, but if you can imagine, the software doesn't know the difference between this boundary and the solid model, so by giving it a boundary I'm limiting the fixture to the height of that boundary. So they're very, very useful, especially in tubular parts where you've got lots of compound angles, etc. They're good for cleaning up geometry. You've got options here to rotate, scale, move, freeform, translate, etc. Again, you can play with those. If I go to the next option here, this is where we can do a grid of components. So I could do 4 of these in X and 3 in Y, so I end up with 12 components in one fixture. So it's a way of doing multiple parts in one fixture. If you do that, you just basically create the grid array, and it will make the base plate bigger, so you can put extra blades in the base plate for the other parts. This is one of the core functions of the software. This is where we draw our fixture lines. So I might say, give me an automatic size, and it will draw them every 3.6 inches. If I'm not happy with that, I can just say I want them 3 and 3, and generate them, and then it's drawn them every 3.3 and 3 inches. Okay. You can also move them, scale them, shrink them. You can add your own lines, user-defined lengths, or ones that fit within a window. There's a myriad of different ways. You don't have to draw the fixture lines over the complete part. Obviously, for this box it makes sense, but if you had a very long part with a tube part with a couple of weldments on each end, you don't need to put fixture blades all the way across the centre of the tube. You can put them just at the ends. It really is up to you how you do it. You have the option there, when you add them, you can add them and undo them, delete lines, etc. You can also make the lines a certain thickness. You can change the thickness from the default 11 gauge material to another thickness. You may want to make a line 1/2 inch or something for some reason. So you can change individual lines to be different thicknesses too. For the sake of our example, I'm going to modify my fixture line positions because I'm not quite happy with them. So I'll go to an XY view, and I'm going to move a couple of these lines. So I'll select the lines to edit. I'm going to select this one, press the enter key, and I'm going to move it down. Let's just change that to a 0.5 increment. I'll move it down on the negative Y, and it's moved it down, and I'll choose another one here. I'll move it up plus Y. I'm going to select these outside ones and move them out a little bit. So I'm going to move them minus X. I'll move this one plus X. And then, I'm happy with that. What I want to do though is my welding torch is going to come into these corners from the outside. So I've got a little bit of a problem getting my torch in here. So what I'll do is I'll just shrink those lines back. So select shrink and select the 4 outside lines. So 1, 2, 3, 4. And then I'll just say shrink them back 2 inches. So minus x, plus x, minus y, plus y. So by having the boundary drawn and these lines on the outside, I've got a stiffer fixture. If I didn't have the boundary, it would be okay. I'll just have these lines wouldn't be interlocked with these lines on the outside, which would probably be rigid enough. But if you want a really rigid fixture, you can do it this way. And having the boundary there gives them the software something to fixture to. So that's why they're quite useful for controlling or adding extra material to a part for the purpose of fixturing. There's also options here to draw a sketch boundary, so you could sketch around the outside of something and remove lines and trim them back. And there's also an option here to do the slots the opposite way. The slots are the interlocking slots where the green and the purple ones interlock. You can reverse that order so that you put the purple ones in second, which we would normally put the purple ones in first and then put the green ones in on top. It just reverses that order. The minimum Z just means that the fixture, if the lines extend outside the solid boundaries, or where there's no solids, it must maintain a minimum Z of 2 inches in this case. In this case, it doesn't matter because none of our lines go outside the boundary or outside the solid bodies, so it doesn't matter. But it's just a minimum Z height to maintain. If I go to the next step, this is where our tab foot is created. I can say, give me a good size. It said 1.8, so I'll just say 1.5 inches. Basically, this is the little tab that goes into the base plate. It just sits in the base plate, and you spot weld it in there. If you put a dimension D in there, however, say you put in like let's put in a 1/2 inch, it will make an interlocking slot. It'll clip into the base plate and lock the whole fixture to the base plate. So it's a way of creating a breakdown fixture where you can put it together, use it for the purpose for the welding run you're doing, and at the end you can break the fixture down, lay it down flat, so it makes it a kind of collapsible fixture. So you can either leave the D0 and then you basically make your base plate your B dimension of material thickness 1196, or you create an interlocking slot at dimension D, and then you make your dimension E would be also 1196, but my B would be bigger. I'll make it 0.25. So B would be a bit thicker, and the dimension E would be my base plate thickness. Of course, once I've got this done, I'm going to have to have the base plate up on some sort of risers or some bushings, which could be bolted through the bolt holes that are on the base plate. But that's really the purpose of this. You can also add your own user-defined positions, etc. This option is for importing solid models of clamps. You can import them and from downloading them from, for instance, Destaco's website. We prepare them as a parasolid and a few preparatory options we have to do to get them correct. But then you can import them and then place them on the model, and it will create a little tower for that particular fixture that particular clamp to sit on top of. Once they're imported, you can reposition them, you can rotate them around XYZ to get them to funny compound angles if needed, but very flexible. We won't go through this process right now, maybe another video on on this part, but again, if you've got your library of clamps, you can save them and re-import them into the model. This option is a additional option which we will also cover in another video, which is for clamping from the top side. It creates a bridge fixture that allows you to locate a component from the top side of the weldment versus as well as the bottom side. So if you had to locate a nut or some kind of cylinder, for instance, in the center of this box on the top side, it allows us to create this hybrid clamp that will locate that, and then you can weld top and bottom. This option is to be continued. It's for weld positions. We're looking at kinematic simulation, welding, creating the weld positions in the model, and then post-processing with kinematic collision checking for any generic welding robot. Something that's coming in the future. For now, we just go next. This option allows us to offset the fixture perimeter. So you can make the blades, the purple and green blades, 10 thousandths bigger, so you've got some clearance. You can also use gripper points. These gripper points just make every distance B, which is 1 inch by default, we could put a 50 thousandths radius. So it'll offset the fixture by 50 thousandths, and every inch put a 50 thou radius there, a bump, and then the part is then just sitting on the bumps on the edge of the blade versus the whole periphery of the blade. Some people like this for less friction, or for adjusting the fixture in the real world you may need to file these bumps down in places. So it's just a way of making the fixture oversized. You can also do that after the fixture is finished with a direct editing option, which again will be in another video, where you can just, after you finish creating the video, you can do direct editing and change discrete geometries inside the fixture. The inset picture here is not used very often, but it's a way where you can insert these slots into the fixture edge, and then you can almost like weave in some low friction material like copper into the fixture, like a basket, so that the component is sitting on this copper material, which isn't going to scratch it. It's very useful for people who are making aluminum boxes who don't want to mar the surface as they pull the component out. So just a different option really there for people who need that. Next step is weight reduction. If you wish, it will try to put, based on these tolerances and values, it will put holes in the fixture. This could be useful for access with a torch, weight reduction, ventilation, so the fixture doesn't get so hot, etc. So you can do it for the base plate and you can do it for the blades. This page sets the corner relief in the base plate. Where the little feet fit into the base plate, we have a little bit of corner relief, Mickey Mouse ears as I call them. You can also give it some oversize, so a little bit of clearance in the X and Y direction too. This option is a Pintar option, where you would have maybe traditionally put a machine pin in a fixture, so you could locate through a feature in the weldment. This does the same thing. What you do is you choose a circle or a square, whatever shape you like, and you pick the edges of the square, and it will then project a tower underneath that position, so you can locate through that feature in the weldment model. There's two types, one for a bigger hole, one for a smaller hole. So you can choose which one suits you for the particular feature you're trying to fit through. Very useful for that, maybe useful for painting fixtures. You can turn off all the other blade lines and just keep the pin tower definition towers, so you could have something you could use for a painting fixture if necessary. This is where we define our bolt hole parameters in the base plate, so we can just do a standard pitch for whatever your robot table has and a diameter. And then you can decide where you want them across the extent, or just on the corners, or just on the edges. Or if you've got a rotary axis, you can actually type in user-defined positions, so they match up to a picture frame you may have attached to your rotary axis. This option is where we set the viewing, how we want to see our parts, translucency. There's a lot of advanced options here for changing the geometry, which again you would normally leave as default, but on the advice of technical support we may change some of these depending on the topography of your component. On the first page or second page I asked about the material thickness, the thinnest rib you would encounter in the model. This is where it's used. So if you typed in 1196, based on that value, it will give us a different set of parameters here. These are very important. They affect the way the fixture is calculated and the accuracy. It's actually outlined in the PDF file, the Getting Started Guide, of what these mean, if you want to refer to those. But for the sake of this, we'll just move on to the next step. This is our final stage, where we can put in a label for the base plate, the offset from the edge, etc., the font size, and whether we want to cut through annotation on the blade. So the first blade will be X1 for the horizontal one, X2 for horizontal 2, X3, etc., and the vertical ones would be, sorry, that was wrong, they would be maybe Y1, Y2, Y3, and then I'll see the vertical ones will be X1, X2, X3. You can also put a part number in here. A lot of these tooltip helps give you assistance on what you can do in addition. Once you're at this stage, you can then do a preview. wait for the fixture to do its preview. Okay, now that's our preview complete. This dialog box comes up, tells you if you've got any trouble. You can go back and check some of these options. You can turn that off actually in the options dialog. You could say there's an option here: do not show completed dialog, and it will not show you that, because after a while you get used to the message. So there's my fixture. I can then toggle it. I can say toggle apart, show me with and without. I can change it to any isometric, to an XY, XZ view, etc. If I'm happy with that, I can create the fixture. If I can go back to any of these steps and I can change any of those options, I can say, I want it to be a little bigger, maybe. I want to extend my lines. I can go back to any option there, any value in each page. But what I'm going to do is create the fixture. Again, it might take a moment to create. It's doing it a little bit quick. It'll be doing it now at a higher resolution and a little more accurate than the preview method. It's generating it now. And there's our box. You'll notice it's got the gripper points on because I selected to use the little bumps, so you'll see that these little bumps along the edge of the periphery included. Base plate, the end. Toggle the part, in and out. These two items here are storage clips, so if you have the option set, if you were to stack all the purple ones together, they would fit in between this slot here, and if you stacked all the green ones, they fit between this slot here. So they're storage clips, so when you lay it down on the shelf, you can just cut as many of these as you like to keep the thing nicely tight, nicely stacked together. So when I'm at this stage now, I now can do my final option to export to DXF. I have options to change what layer the geometry goes on, what layer the etching goes on, and different colours, etc. You can also scale the DXF if you so wish. I export to DXF. I can choose a folder. It does a backup file for me. Then it takes each individual blade and exports it to DXF. You can see on each blade the etching will be on each one. Do the base plate next. Take some screenshots. And it'll actually bring me on my other screen a report of the area of each component and the cumulative size, so how much material you need to cut the fixture out. I click done. I can then save my component if I wish, or I could export it. So if I went to the file, I can do a data exchange and I can export it to a parasolid or a 3D IGES, and I can import it into another CAD system if I so wish. With regard to where the location of the files are, I have mine on my C drive. And under temp, box Nucleo fixture files, and then in here we've got each particular DXF, and then we've got a picture of each one and the report, which we just mentioned with the usage of the sheet metal. So that's really it. That's it in a nutshell, the process from A to Z. There are some advanced options we would do different videos for, which I discussed, the clamping and the direct editing. But that's a getting started guide. If you have any questions, please email us at support@camtech-software.com. Thank you.